In this video, I'll be explaining how to find the area under the standard normal curve for the following problems. Here, I want you to recall that for the standard normal distribution, the mean is always going to be 0 and the sigma is always going to be 1. Now, in this problem, we're interested in finding the probability that the random variable z is greater than 0.85. Now, also before doing this, I would like you to know that to get the probability that z is in an interval. Okay, so here you can use the normal PDF approach, a normal CDF approach, where you have the lower bound, the upper bound, mu, comma sigma. This is the general approach, and recall that mean is always 0 and sigma is always 1. So this is the general approach to show that you have z in a particular interval. Now, to do this problem here, there's a need for me to draw the normal curve. So drawing the normal curve, we have the random variable as z, and the center, which is the mean, is always going to be 0. Now, we are interested in to show that z is greater than 0.85. So 0.85 is going to be to the right of 0, which is going to be here. So we have 0.85 over here. Now, if you look at this sign here, we're talking about greater than, which means we are interested in the area to the right. So we are interested in the area to this right. Now, using the normal CDF approach, so here we have the normal CDF. The lower bound is going to be the starting point, which is 0.85. And what about the upper bound? The upper bound is where it ends. For a normal distribution, it is a continuous distribution. So it ranges from negative infinity to positive infinity. So this means that here we're going to positive infinity. But since we are going to be using calculator, instead of writing positive infinity, I'm going to use 1e99. What this means is that 1 times 10 to the power of 99. This is extremely a very large number. So this is going to indicate our infinity. So here I'm going to have 1e99, comma, the mean, which is going to be 0 here, and sigma, which is going to be 1. Now let's see the probability or the area that falls in this region. So now to get that from your calculator, the first thing you have to do is to press on the second button, and here you go to the distribution. Then after this, let's come straight to normal CDF, which is the second in this line. Now, what is the lower boundary? We have 0.85. And the upper boundary is infinity, which is 1e99. So I have my 1. To get the e, just press second button, which is this blue button, and you press on the comma over here, which you can see you have the double e over here. Then you have the 99. The mean is 0, sigma is 1, and you can paste the answer to this. So this shows you that here we have 0.1977 approximately, or you can say that we have 19.77%. This means the area covered over here is 19.77% to the right of 0.85. This is how you do it when you have greater than. Now, what if you have this interval whereby you have the minimum and you have the lower and you have the upper? So here we're interested in calculating the probability that our random variable z is going to be between 0.85 to positive 0.85. Now, doing this, drawing the normal curve as usual, which is going to help you a lot to determine how the shape behaves. Recall the random variable is still going to be z, and here we have the center, which is the mean, as 0. So here we have negative 0.85, which is going to be to the left of 0, negative 0.85. And we also have positive 0.85, which is going to be to the right of 0. Here we have positive 0.85. So we are interested in the area under this region. Okay, so now using the same normal CDF approach, here we have the normal CDF. Our lower bound is going to be 0.85, which is the starting point, negative 0.85. And the upper bound is going to be this, which is 0.85. The mean is 0 as usual, and sigma is 1. Okay, now getting this probability from the calculator using the same approach, we have second distribution, normal CDF. So here we have the lower bound to be negative 0.85. Now, to get the negative, don't use this negative sign. Don't use this, okay? Don't use this negative sign. Instead, we use this. So we have the negative 0.85. And for the upper bound, we have a positive 0.85. The mean will remain 0, sigma remain 1. Then you can paste. You can see the normal CDF negative 0.85, positive 0.85, 0, 1. So we have 0.6047 approximately. So the area under this curve is 0.6. And recall, for a normal distribution, the total area is going to be 1. So this gives this. Or you can say that we have 60.47%. The total area for a normal curve can be 1 or 100%, either way. Now, looking at this question C, we have the probability that Z is less than 0.85 negative. Now, we are interested in the area to the left. Now, doing this, drawing the same normal curve as usual, with our random variable as Z and the center as 0, which is the mean. So here we have negative 0.85. We are interested in the less than sign. This shows that we are interested in the area to the left of 0.85. Okay, now here, using the same normal CDF, the lower bound is going to be from negative infinity, which is negative 1e99. And this is going to be our upper bound, which is negative 0.85. We have 0, we have 1. Now, doing this from the calculator using the same approach, second distribution, the normal CDF. Here we have the negative 1e, which is second, and this sign, 99. And the upper bound is still also negative 0.85. Mean remain as 0, sigma remain as 1. And we paste, which is 0.1977. Now, I want you to have a look at this answer and the first answer. You can see they are the same. This is to the right of 0.85. This is to the left of negative 0.85. What can you notice over here? This is one of the properties of normal distribution, and we call it symmetry. A normal distribution is symmetric. Okay, it is symmetrical. So these are going to be the same. Okay, to the left of this or to the right of the same thing are going to be the same. So I want you to do part D and put the answer in the comment section. Okay, let's see if you understand it. Thank you very much for watching. See you next time. Bye.